All right, we'll get started. So good afternoon again, everyone that was already there before, and good afternoon to people that have just logged on. I'll just go through to the next slide. So a quick introduction. My name's Pat. I've also got Joel helping me out today. So Joel is our sales engineer based up in Queensland. I look after our FSP program and also am a sales engineer as well, looking after some other accounts based down in Victoria. All right, so what's on the agenda today? Essentially, we're going to go over what multi-inverter export control is and the requirements for setting it up. We're also going to go over the capability of this function and some examples. And then lastly, we'll run you through how to set it up. So it should be a relatively quick session. But yes, we never know with questions, etc. But hopefully we're out of here fairly soon. Okay. So what is multi-inverter export control? So what we're talking about here is ability to connect two or more Fronius inverters together and then configure the export limiting settings for those inverters natively. So that's without any third-party device or software. So prior to the 1.32 software release for the pilot monitoring card, so that's the monitoring cards that goes in the Gen 24 or our Tauro inverters, and when we do have the Verto, which is soon to be in the market, it'll be the same monitoring card that's in that inverter as well. So prior to this software release, you could only control multiple SnapINverters natively for export control, right? And those were physically connected to each other with an Ethernet cable, or we call it daisy chaining, and I'll talk about that in a little bit as well, right? So other than that, if you had a mix of, say, SnapINverters and Gen 24s, for example, then you had to use a third-party device, right? So now we can do this natively with all of our inverters that we currently have out. So the Gen 24s, Tauros, and the SnapINverters, and then the Verto when it comes as well. What I want to make clear here is that this function, this export limit function, only relates to standard export limiting, okay? So we're not talking about flexible exports. We're still working on that, and we're hoping to have it ready later in the year. But for right now, it's just standard export limiting, okay? So what are the requirements? Let's go through that. So first off, we need a master inverter, okay? That master inverter has to have a pilot monitoring card. So as I said, that's your Gen 24, Tauro, or the Verto when it comes out. And that monitoring card needs to have firmware with at least 1.32 on it. So 1.32 or above, right? Any firmwares above that, okay? So that's your master inverter. Then you need a Fronius smart meter. So that's basically any smart meter that we've got in our range right now, and even a couple of discontinued models. So the 480 volt UL and 240 volt UL are discontinued, but they will work as well. But otherwise, you've got all those other ones, the direct connect versions, 63 amp 1 and 63 amp 3, your 50 KA WR meter, and then the IP meter, which can also be used wirelessly. All right, then you have your slave inverters. So you're going to have this master inverter controlling the other slave inverters, okay? And you can have a maximum of 19 slave inverters. So all up, that's 20 inverters, one master and up to 19 slave inverters, okay? So that could be Gen 24s, those could be Tauros, Vertos, or your SnapINverters, okay? And then finally, you need a router, which is a central connection point for all of these inverters, and that forms the hub of the control system. So all of these inverters, the master inverter and the slave inverters, need to be on the same network, okay, the same internet network. The master inverter is going to communicate with the slave inverters via the router, and the communication protocol is Modbus TCP. So it's essential to ensure you have a strong, reliable network connection between the inverters and the router, right? So just to, again, reiterate that, it's over the network. There's no hardwired connection between the master inverter and your slave inverters, okay? Like how we used to daisy chain the snaps before. Okay, just on Wi-Fi connection, if you choose to do Wi-Fi as opposed to a hardwired LAN connection, right? If you're using Wi-Fi, make sure that your signal has at least 2 bars like this shown in that picture. So half of that, you know, pizza slice looking thing. So that corresponds to a connection of at least -59 dBm, or just a decibel milliwatts, right? Milliwatts. So either -59 dBm or better. Okay. So some example configurations. This first one, we have multiple Gen 24s. So 4 Gen 24s there. We have a battery as well. Remember, when we're doing multi-inverter export control and you have multiple Gen 24s, then you can only have batteries on one of those Gen 24s, okay? Now, for proper control of the battery, that inverter that has the battery on it would require a smart meter. So that inverter is going to end up being your master inverter for export control, because the master inverter has to have that smart meter connected to it, okay, to control the rest of these slaves, which is happening through the router, okay? In this example here, we've got the Gen 24 and a battery. So again, that's going to be a master inverter. And when you look at all these other inverters, they're SnapINverters. So remember, the master inverter has to be one with a pilot monitoring card. The SnapINverters have a Datamanager card, so different monitoring cards. So they couldn't be the master inverter anyway. So you got your master inverter, you've got the battery connected to it, you've got a smart meter connected to that master inverter. Again, you've got your router. And then what we have here is multiple groups of SnapINverters. We've got one group here, second, third, fourth, okay? And each of these groups form a solar net loop, right? So what that means is these inverters are daisy chained together, okay? So this solar net loop, when we talk about that, that only relates to SnapINverters because they're the only ones in our portfolio that can be daisy chained with an Ethernet cable, right? So usually with a solar net loop, you can have many inverters in that chain, like quite a lot of them, hypothetically. But when we're talking about multi-inverter export control over the network using Modbus TCP, which is what this webinar is about, then in each solar net loop, in each of these groups, we can have a maximum of 5 inverters, okay? So it's different to what you'd usually be able to do with a solar net loop if we weren't talking about this export control over the network, okay? So how a solar net loop works is each of these inverters here, right, will have an active Datamanager card, an active monitoring card, and they're controlling the other inverters that are daisy chained to them, okay? So we refer to this inverter with the monitoring card as a master, and we refer to these inverters as slaves to that master inverter, right? So the rest of the inverters in the chain or in the solar net loop are slaves. Now, I know that could be a little bit confusing as we're using the term master and slave again. So let's just go over that to make sure we understand what's going on. So looking at this example, when we're talking about multi-inverter export control, which is happening over the network using Modbus TCP, you have the Gen 24, which is a master, and that master is essentially communicating with all of these slaves, right? So in this examples, it's these 12 SnapINverters that are slaves to this Gen 24, which is the master, right? So the other thing is that only these master inverters for the solar net loop are the ones that have the Datamanager card, which is active, okay? So, or to put it another way, these inverters are communicating with the SnapINverters that are daisy chained to them, okay? So here we have 4 solar net loops, or 4 groups of inverters. So for each solar net loop, we also use the terminology of master and slave. So we have the master snap inverter and its slaves, okay? So this master is communicating with each of these masters who are communicating with their slaves, all right? So it's 2 different masters and slaves. I really hope that makes sense and that's clear. But if you have any questions, just pop it in the chat, okay? All right, so looking at that solar net loop, just to give you a bit of a recap, right? So the solar net loop is where you have multiple snap inverters daisy chained together. So on each snap inverter, you will usually have RJ45 plugs. So that's these guys, right? That are on the terminals labeled in and out, okay? So what you do is you leave the RJ45 plug on the master inverter on the in terminal, okay? So that's the master inverter, okay, number 1 inverter. And then you have an Ethernet cable going from the out terminal of the master inverter to the in terminal of the first slave inverter, and then from the out terminal of this slave inverter to the in terminal of the next slave inverter, and so forth until you get to the last snap inverter in the chain, right? And then you have another RJ45 plug on the out terminal, right? So that therefore the loop is closed there, okay? So as I said, when we're talking about multi-inverter export limiting, it's a maximum of 5 inverters in that solar net loop, okay? And your cable length for that whole solar net loop needs to be under 1,000 meters. Pretty much it's always the case that that's how it would be. Then on the display screen to set it up, so you go to each inverter, you go to setup, you go to DATCOM, you go to inverter number, okay? And then you set these inverter numbers for each inverter in the chain. So it's always easiest and best to do it consecutively. So the master inverter is 1, and then the next slave inverter is 2, etc. Right? So just do it consecutively and you won't get confused. So that's a quick recap of the solar net loop. All right, so last example here, we just have a mix of different inverters. Again, we've got 2 Gen 24s here, so we've got Gen 24s, we've got a Tauro in the mix now, and we've got some snap inverters again, right? So here you can see these ones are daisy chained to this snap inverter, okay? So it's got its connection to the router, the Tauro's got its connection to the router, the master inverter, which has a battery, so it has to be the master inverter, this one, that's got its connection to the router, and then you've got this other Gen 24, which also has a connection to the router, okay? So just a different example, same principles as before, but just different types of inverters, okay? All right, so how do we set this up? So we need to apply settings within the inverter's web UI or the inverter interface, okay? So with your Gen 24s or your Tauros, for example, you just hover your finger over the sensor button, right? And the Wi-Fi access point would become active, and then you connect to that Wi-Fi access point using a smart device, such as a smartphone or a laptop, etc. So connect to it like it is a Wi-Fi network, right? And then go on your smart device, open up a web browser, and then head to the IP address 192.168.250.181. I'm sure that number is burned into the memories of many people listening to this webinar today, if you're familiar with configuring Fronius inverters. So before configuring the master inverter, all the other slave inverters in the system should be commissioned and connected to that same network that the master inverter is going to be on. So you need to set up their connection to the internet network on site and then also configure some settings, right? So once you're in the inverter's web UI, what you want to do is open up the menu, okay? Go to communication here, okay? You will have to use your technician password as well, okay? And then what you want to do is you're basically setting up a few different functions there, right? So there's activating Modbus as slave, setting up some fallback and failsafe functions and values, setting controlling priorities, and then deactivating ramp up communication. So first I'll show you how to set up the Modbus settings. So communication, as I said, right? Then once in communication, open the Modbus or click on Modbus, and open that menu, okay? And then once in the Modbus menu, you want to activate slave as Modbus TCP, and you also want to activate inverter control via Modbus, okay? Then to set up a fallback or a failsafe function and value, so you click on safety and grid regulations from the main menu, okay? And then once in that menu, select export limitation, okay? Then activate power control, okay? And what you want to do is enter the total DC power of the entire system, okay? Activate export control with a soft limit and then set the fallback value. So that you can see it's got percentage of watts. Always select watts because that's just much easier, okay? So the fallback value can be set to a site-specific target, or it can be set to 0 watts, okay? So an example is you might have a system with 3 Gen 24 10 kilowatt inverters, okay? So 30 kilowatt in total AC capacity, right? And say your total export limit for the site is 10 kilowatts, okay? So you have 1 master and 2 slaves, okay? And I'm going to show you what you do with the master inverter in terms of fail-safe settings, right? But right now we're just configuring the slaves, okay? So in this case, what you could do is set the export limit for each slave to 5,000 watts, right? So that means each slave could potentially be giving out a total of 5,000 watts, which adds up to 10 kilowatts. And the master inverter basically won't do anything. It won't export anything, and I'll show you that in a bit. And therefore, if as a fail-safe, if communication was lost, the maximum that it would put out is the export limit of 10 kilowatts, okay? Just from those 2 slave inverters, okay? And that's basically it. You'll just click on the save button to save those settings, okay? And then we need to set controlling priorities. So in safety and grid regulations, you go to IO power management, okay? And then you want to set it as IO power limit as priority number 1, Modbus control as number 2, and export limitation as number 3, okay? Now you may be wondering, why is IO power limit set as priority number 1 instead of Modbus control if these settings, you know, the communication is via Modbus control, okay? So this IO power limit setting, or priority, sorry, we leave it like this, not because it's for a specific function to do with multi-inverter export control, but it's just to make sure the IOs are used first if needed, in case they're used for, say, shutdowns with DRM, such as or the GSD device, you know, up in Queensland. So, or if you have, say, a Tesla Powerwall 2 on site, we need to ramp down an inverter when it goes into backup mode. If you have a Tesla Powerwall 2 on site, for example, that could be another reason. But that's why we put that as priority number 1, okay? And then again, just save those settings. And then in order to allow the inverter to ramp without delay, right? So without any gradient, the ramp up communication needs to be disabled, okay? So usually we need a delay. We need the delay in place as a safety feature, right? But when it's one inverter, we don't want it to ramp up too quickly or down too quickly, right? But now, as there are multiple inverters in this network communicating over Modbus TCP via the router, there's going to be a slight delay with the communication via Modbus TCP. And by turning on this this setting, for the delay, we're basically offsetting that delay that's going to be introduced by this Modbus TCP communication. So that's why we turn it off, right? So where do you do that? You go into safety and grid regulations, then country setup, okay? It will ask you for an access code, which is 77634. Then you click unlock, okay? And then from there, you go to the general section, you scroll down to ramp up communication, and you select off, okay? And then you set it to, then you press save to save those settings, okay? So now we've finished configuring the slaves. The next thing to do is to set up your master inverter, okay? So again, you're going to connect to the inverter's web interface, all right? And then essentially what you're going to do is go to safety and grid regulations and then export limitation, okay? And then you're going to activate power control. You put in the total DC power of the system in watts there, right? And then you're going to put in your export limit, okay? So that's your total site export limit. Again, you put it in watts, okay? So if it was a 5 kilowatt export limit, you put in 5,000 there, okay? And then you put this setting in, which is reduce inverter power to 0% if meter connection has been lost. So that is your fail-safe for the master inverter. So if we remember what I was saying before, if there's a loss of internet connection, this is going to reduce to 0. So it's not going to export anything. And then your slave inverters, you're going to put in a soft export limit there of whatever it is to add up to your total site export limit, okay? All right, then once you've done that, you click on limit multiple inverters, okay? And then you can either select use all inverters if you're using all those inverters that you can see there, right? Or otherwise you just select which inverters you want to be export limited and then click on save, okay? Now here, where it lists all those slave inverters, you need to make sure they're all connected and show like this, right? Shown here in green, okay? If it says inactive like this, it means that the inverter is on the same network, right? So that's why the master inverter can see it, and it's coming up in the list of inverters here, but perhaps Modbus control isn't activated as yet, okay? If it says disconnected, okay, it could mean that the inverter was configured, so that's why it's showing up there, but currently it doesn't have a connection to the network. So, you know, making sure you have that strong network connection via Wi-Fi or of -59 dBm or better, or you know, just making sure your connections are fine, as that could be something to check. Or there could be an issue with the Modbus connection, right? It could be that it's not responding for whatever reason, okay? So that's what inactive, disconnected, and connected refers to. And when you have it connected, the slave inverter is basically ready to be controlled by the master inverter, okay? All right, so that's how you do all the settings on the slave inverters, which have a pilot monitoring card, and also the master inverter, which has to have a pilot monitoring card, okay? And now I'm going to hand it over to Joel, and what he's going to do is show you how to do those settings for the slave inverters on SnapINverters, right? Remember, SnapINverters can't be a master inverter because they don't have a pilot monitoring card. They can only be slaves when we're talking about multi-inverter export control over the network. And yeah, I'll hand it over to Joel and he'll take you through that.
Awesome, thanks Pat. So, like your Gen 24s or your Tauros and soon to be Vertos, so we need to connect to the inverter's web UI like we do with a pilot card. So activate the inverter's Wi-Fi access point, connect to the Wi-Fi access point with a smart device, and open up the web browser, head to the IP address and type in 192.168.250 0.181. As Pat said, if you've been using Fronius products and commissioning our inverters, that number would be burnt into your brain. So once you're in the inverter's web UI, we need you to go to the right-hand side and select settings. Over to the left-hand menu, you can see Modbus tab. So if we select Modbus, and we want to set the data export via Modbus. Again, the communication is done by Modbus TCP, so we're selecting the TCP and checking that. Then you want to go down to the inverter control via Modbus and select that. And then we want to click on the tick and save those settings. Now, once we've done that, we need to set up the fallback or fall safe function as Pat mentioned before. To do that, we want to go to the left-hand menu, and all the way down on the bottom left-hand corner, you can see DNO editor. Select that menu, and then we can set the fallback or fail-safe function. Now, once you're in there, you might want to scroll down a little bit till you hit dynamic power reduction. And we want to limit the entire system. So make sure you select the limit entire system. And then down where it says total DC power out the system, it's not mandatory, but you can put in your total DC power and then onto your soft export limitation value. As Pat mentioned before, you're setting your total watt export limit on site. So if you've got a 20 kilowatt export limit on site, you would set 20,000 watts. It means then that if you've got 3 10 kilowatt inverters, then you'd be setting 10 kilowatts per inverter for your slaves and keeping the master at 0. This is really important if you lose connection, that your system can still produce at least your export limitation value. Now, once you've done that, select the tick at the top right-hand corner and save the settings again. Now, once again, on the Datamanager card, we also need to set controlling priorities. So make sure, as Pat mentioned before, the IO control is set to number 1. Number 2 is controlling via Modbus. And number 3 is your dynamic power reduction. Awesome. Now, again, with the SnapINverters, it's a little bit different, but we need to deactivate the power gradient ramp up function. Now, this is so the inverter ramps up its power with no delay of gradient when it's operating via the Modbus TCP. Now, we want to access the SnapINverters LCD display. You need to get into the hidden menu by selecting the second button from the right. Just click it a couple of times and you'll see the access code will say 5 zeros. If you put in the access code of 77634, that'll allow you to get into these settings. Now, if we click power change gradients, then up ramp, and then turn that off. Nice and easy. Now, of course, we want to see all of our inverters and all of our slaves on the SolarWeb. So there's a really easy way to achieve that. You can either do it directly when you're creating the PD system or after the fact. Now, after the fact, if you go into the PD system plant, go to settings in the top menu, select components, and then add a new device, then you can have complete visibility over all of your systems in SolarWeb. Just to quickly summarize, there's a maximum of 20 inverters, including your master and your slaves, for this Modbus TCP export limitation feature. Now, one Fronius smart meter is required. You can use any of our Fronius smart meters. Just make sure you select the right smart meter for the right function and application. A maximum of 1 Gen 24 plus with a battery. Make sure that's your master. That's linked with your Fronius smart meter as well. And a maximum of 5 SnapINverters per solar net loop. Now, all inverters need to be on the same network. Make sure you've got a strong network so this operates properly. And Bob's your uncle. Now, we're going to hand it over to Pat. He's going to answer some of your questions. Thank you guys for listening.
Fantastic. Thanks, Joel. All right, so there's been some questions put in the chat already, and feel free to populate it with any further questions. Someone's asked about where to find the handouts. So there might not be attached, it will just be the slides anyway. The document on how to configure this is almost ready. Hopefully it's ready, within the next few days, and we can send it out with the slides, but we'll send out at least the slides. And if we have the application note on how to configure this, the PDF, we'll also attach that to the email to all the attendees, okay? All right, if you purchase a Gen 24 at the beginning of the year, do you need to buy the pilot card and retrofit it? No, the Gen 24 would already have the pilot card in it. All you'd need to do is just make sure that the firmware is on the 1.32 release or above, you know, any firmware above that, but basically make sure it's on the latest firmware, and that's all you need to do. What about the SIMO Advanced series as a slave inverter? So yeah, they can also be used. That's a SnapINverter essentially. So they can also be used as slave inverters as well. Okay. Is there going to be a possibility in the future with multiple Gen 24 pluses and multiple batteries? So I assume you mean batteries on each of those inverters while you're doing the multi-inverter export control. Great question. I hope so. I'll have to check in with the team and come back to you on that. All right, how would we set up this on a two-phase site? So single-phase inverter per phase, and then you have a total site limit of export limit of 5 kilowatts. Battery connected to one of the inverters. So that inverter that has a battery, you'd have the smart meter connected to that one. I would be using a multi-phase meter, so you can read both of the phases, okay? And then from there, you'd set it up just like we did with the master inverter and the slave inverter, okay? And you'd asked about a horizontal line, and if that's Modbus or if it's only LAN connection is enough. I'm not quite sure I follow, but essentially between your inverters and the router, it can be a hardwired connection, so that's a LAN connection, or you could do a Wi-Fi connection as long as it's connected to that router, and then your Modbus TCP communication is happening over the network through that router to each of the inverters in the mix, okay? Can we already do this with the pilot, with the Tauro and Gen 24? Yes, because that 1.32 firmware release is out now. So, and then all subsequent firmware releases will also have the same capability, okay? So yes, you can do this right now. If the communication is lost, how does the slave inverter know what the energy meter is doing in order to export limit to 5 kilowatts? Or do you mean max production is 5 kilowatts if the comms is lost? Yeah, so essentially it doesn't know because it won't know what's happening because that smart meter is connected to the master inverter, okay? But the slave inverter will, because you put in that setting of 5 kilowatts, it'll go to a maximum production of 5 kilowatts, okay? So that's what I meant. Yes, we will have a PDF guide. I think I mentioned that at the start, Dean. So once that's ready, hopefully it's ready in time with the slides, we can send it out together. But otherwise, that should be ready fairly soon. Can you add a secondary meter to measure non-Fronius inverters in this system? Carl, I believe that should be okay, but let me check with the team and I will come back to you. Do the SolarNet slave devices count towards the 20 device limit or just the masters of each SolarNet chain? No, those SolarNet slaves also count to the limit of 20 inverters. Okay, so it's not just the masters of each SolarNet loop, it's all of the inverters in that loop will be part of the 20 inverters, okay? When will it be available? As I said, it's available right now with the 1.32 release. So as long as you have that installed on the inverters or the master inverter, so to speak, when is the 15 kilowatt? When is the 15 kilowatt Gen 24 going to be released? We have a 12 kilowatt Gen 24 coming later in the year, but not a 15 kilowatt this year. I'm not sure of exact dates for a 15 kilowatt hybrid. The Wi-Fi connection is the best frequency, 2.4 gigahertz back to the modem. Yes, that is the case. For the monitoring, will there be unified data for all inverters, or will we still be able to view individual performance? I believe you'll only be able to look at individual performance under the analysis tab. On the bubble chart, it would be unified, but I can double check that and come back to you. For existing sites that have been waiting for this firmware, is there any way we can apply these settings remotely, or does it have to be via the inverter web UI? It does have to be done via the inverter web UI. If you activate remote access, then potentially we could help out with this on our side. We are also working, I can't give you exact dates right now, but should be here hopefully fairly soon, where you'll be able to get in and configure settings remotely. I'm not sure exactly how that's set up and how it's enabled in the first place, but that potentially could be a workaround. But I'll look into that and come back to you, Kieran, okay? Do we still add the slaves to the solar website, or is all the data via the master? Now, you'd still add all of those slaves to the solar web monitoring portal, okay? Someone that asked about connection of an ohm pilot, especially if it's already on the SnapInverter in the existing system. I would say that would need to be changed to the master inverter. Connected there, because it'll have the smart meter connected to it. I will check on that and let you know, Graham, but I think that's probably the case. Do SnapInverters need to be on the firmware 1.32? So that firmware is actually only for the pilot monitoring card, so it's irrelevant for the SnapInverters. It needs to be on 1.32 for the ones with the pilot monitoring card, okay? All right, so we're pretty much run out of time now. We've got through pretty much all the questions. If there's any that I missed, I will come back to you via email and make sure that your question was addressed. Or if you have my email address, you can just reach out to me or give me a call, etc. Or even Joel, I'm sure he'd be happy to help. Or any of your sales engineers, your relevant sales engineers will also be able to help with this stuff as well. We'll leave it there. Thanks again, everyone, for tuning in today. I hope you found that easy enough to understand. And as I said, if you have any further questions, don't hesitate to sing out, and we'd be more than happy to help. All right, thanks. See you guys.
Thanks, everyone.
Bye.
Bye.